Hello students. So today we will start refraction formula through curved surface. Okay. So in optics, there is a formula. It is called refraction formula on the curved surface. So today we will start. We will derive the formula of that one, and then we will do some numerical based question on this topic. Okay. So first we are going to derive a formula by using refraction formula. Okay, Snell's law. So let's say there is a curved surface, and this curved surface is separated by two different medium. One side medium is N1, this side medium is N1, and this side medium is N2. Okay. Let's say there is an object here, this side. So incident ray fall on this surface. Let's say the radius of curvature of this surface is R, radius of curvature. So light will fall on the curved surface, and let's say after refraction, it meet here. So image will form here of the object. Okay. One more ray will go along this direction, and since there is angle of incidence 0, so the light will go before without deviation. So so these two light rays will meet at the point I. So this is the image of the object in the medium N. So N1 is the medium having refracted ray, and N2 is the N1 is the medium having incident ray, and N2 is the medium having refracted ray. Okay. Now at the point A, let's say this point is A, refraction is happening, so there is deviation of the light. So we will apply here Snell's law. So let's say this is the center of curvature of this surface. So let's say this is the center of curvature of the surface. So when you draw the normal at point A, it will pass through center of curvature of the surface. This is the normal. This is the normal of the point A. So let's say the angle of incidence is I, this angle is I, and angle of refraction is R. Okay. And let's say these angles, this angle is alpha, this angle is beta, and this angle is gamma. Okay. And we are measuring the point distance from point P. P is the middle point of the refract of the surface. Okay. So what are the distances? OP, we will measure all the distance from P. So OP is the object distance, PC is the radius of curvature, and Pi is the image distance. Okay. So how we will take the sign convention in this case? So all the distance we will measure from P, and according to the sign convention, the light, the direction in the direction of the sign in the direction of incident ray we take positive. So this is the direction of incident ray. So this direction we will take positive, and this is the opposite direction of incident ray. So this direction we will take negative. Okay. So now if you this if you see OP distance, so OP is the object distance, and it is measured in negative direction. So you will write minus U. CP is the center of curvature from P, and this is the R, radius of curvature, and it is also in left side, and left side we are taking negative, so it is minus R. Pi is the image distance, and it is right side, so we will take plus P. So this side direction, right side direction we are taking positive, and left side direction we are taking negative. All the distance we are measuring from P. I is the right side, so image distance will plus object and center of curvature is left side. So object distance and radius is minus R. Now students, what we are going to do? So we are going to find the relation between the angles alpha, beta, gamma, I and R. Okay. So for that, what we will write? If you see here, beta you can write beta is exterior angle. So beta you can write beta equal to I plus alpha. So you can write beta is equal to I plus alpha. can write beta equal to I plus alpha. Okay, right? And if you see the bigger triangle, this bigger triangle ACI, R is the exterior angle. So you can also write R equal to beta plus gamma. So you can also write R equal to beta plus gamma. So from this equation, beta equal to I plus alpha, you can find value of I. So I is equal to beta minus alpha. And from second equation, R is equal to beta plus gamma, you get the value of R. So you get the value of I and R. Now you can apply a Snell's law at the point A. So you can write apply Snell's law at point A. So apply a Snell's law at point A. So what you will write at point A, Snell's law. So formula is N1 sin I equal to N2 sin R. So you will write N1 sin I is equal to N2 sin R. Okay. After that, we will derive this formula only for paraxial rays. So what are the paraxial rays? So for paraxial rays are the rays which is very close to principal axis. So for paraxial rays, all angles are very small. All angles are very small. So for paraxial rays, all angles are very small. So what we will do, you can write N1 sin I is equal to N2 sin R. So sin I you can write I. Angles are very small, so sin theta you can write theta. So sin I we can write N1 I is equal to N2 R. Okay. Now if you draw a perpendicular here, draw from a here perpendicular. Let's say this perpendicular meets at the principal axis at N. So now you can also write, if angle is very small, so you can also write I is approximately, or theta is approximately tan theta. So N1 into tan I is equal to N2 into tan R. So when you apply this, when you put the value of I value, if you put the values of I here, or before putting this, what you can, before writing tan, you can write like this. N1 into I value is how much? Beta minus alpha is equal to N2 into R value. This is the values beta plus gamma. So now beta plus gamma. So now N1 into beta minus N1 into alpha equal to N2 into beta plus N2 into gamma. Now make same angle same side. So if you try to make same angle same side, so what you will do? Here is beta, so make beta beta same side and the alpha and gamma same side. So take this N1 alpha right side. So it will become N1 alpha plus N2 gamma is equal to N1 beta minus N2 beta. So you will get N1 alpha plus N2 gamma. Now you can write N1 into alpha, you can write tan alpha plus N2 into tan gamma is equal to N1 minus N2 into beta, you can write tan beta. Now at the place of tan alpha, what you will write? Tan alpha. So see at the place of tan alpha, what you can write? So N1 into, in this triangle OAN, tan alpha will be what? N by ON. So you can write N by ON plus N2 into tan gamma. Tan gamma you can write N by tan gamma in this triangle you can write N by Ni. N by Ni. N by Ni is equal to N1 minus N2. Tan beta, what you can write tan beta? So tan beta equal to N by Cn. N by Cn. Now, since the rays are very close to principal axis, so N is also very close to P. N is very close to P. So you can write at the place of N, you can write P. So OP you can ON you can write OP, CN you can write CP, and IN you can write IP. So at the place of this N cancel. So N by at the place of ON you can write OP plus N2 by NI you can write Pi is equal to N1 minus N2 into pi Cn, you can write Cp. Now put these values. Put these values OP, Cp and Pi in the equation. So what you will get? So you will get what? You put these values. So you are going to get what you are going to get. So implies N1 by OP. What is OP? So OP is minus U. So N1 by minus U plus N2 by Pi. So N2 by Pi. Pi is how much? Plus B is equal to N1 minus N2 by Cp. So N1 minus N2 by Cp is how much? Cp is minus R. So what you get? N2 by B minus N1 by U equal to minus take upper. So N2 minus N1 by. So this is the relation we got. This is the relation we got between N1 and N2. This is the formula. This is the relation we got. So we got N2 by B minus N1 by U equal to N2 minus N1 by M. So, so it is very important to note that N2 is what? So N2 is the refractive index. Refractive index having a refracted light. Refractive index having refracted light. V is the image distance. Image distance. N1 is refractive index having incident light, incident ray, and U is what? Object distance. Okay, and R is the radius of curvature. So it is very important to note that whenever we will apply this formula in the question, sign convention should be taken proper. And what we have taken sign convention? So we have taken sign convention in the direction of incident ray, we will take plus. In the direction opposite of incident ray, we will take minus. So this is the formula. This is called refraction through. This is called refraction through. This is the called formula of refraction through curved surface. Okay. Now we can take some questions based on this formula. So if you take some examples, this formula,